Hello and welcome to today's class. We want to look at another aspect in calculus under differentiation, and that will be function of function, all right, otherwise known as the chain rule. Now, let's assume that we have y given as a function of, let's say, 2x plus 5 raised to power n. Okay, now this function of this I have written down. You can see y is in terms of this entire function. However, this one inside can be written as what? As u, because u is a function of what? X. Or it can be written as v, where v is a function of x. So if I write this out, then my y will be, if I write it as u, will be equals to u raised to power n, where u equals 2x plus 5. And so if I have it like this, then I can get the derivative in this form, that dy over dx equals to dy over du multiplied by du over dx. You can see that what is on the right is the same as what is on the left, because by the time du cancel du, you get back to du over dx. So this is called the chain rule. All right. Now let's take a question here. Let's look at a question. If we have this example, if y equals 3x plus 5 raised to power 4, determine dy over dx. So we want to get dy over dx in this equation. Now, we know that our dy over dx equals to, from chain rule, equals to dy over du times du over dx. If you remember this, it's good to always write it. Now that we've written it, the question is, what's our u? Our u is 3x plus 5. And so our du over dx, that is the derivative of this with respect to x. If you derive 3x, you will have 3. However, the derivative of a constant is 0, so that is just 3. And then our y here will be u raised to power 4. Okay, and our dy over dx, our dy with respect to u will be 4u raised to power 3. Remember from power rule that we can get the derivative of u raised to power 4 as 4u raised to power 3. If that is the case, we will go ahead and represent this. So dy over dx equals, what is our dy over du? We got it to be 4u raised to power 3 times, what's our du over dx? We got it as 3, isn't it? And this will be 12u raised to power 3. Remember, the u is 3x plus 5. So when you are writing your final answer, always remember to remove u and impute that substitution of u back to the equation. So our dy over dx will now be 12 3x plus 5 raised to power 3. And so that is our final answer. Hello, welcome to this video. This is another question that enables us to apply the chain rule. Here we are given y to be equals tan 4x plus 1. Look at this closely. Whenever you are given a function of this, just know that you are using the chain rule or function of function. Now, remember, from this we can say our u equals to what? Our u equals to 4x plus 1. That is the angle in terms of x. And then our du over dx will be what? 4. Here, if our u is this, it means that our y entirely is tan u. Our y entirely is tan u, and then our dy with respect to u is sec square u. Okay, we have sec square u. That's what we are going to get. Now, if that is the case, remember that dy over dx from chain rule equals to dy over du multiplied by du over what? Dx. This is what we have. Now, from here now, we can, what is dy over du? Our dy over du is sec square u. And what is our du over dx? Our du over dx is 4. Multiplying them together, our dy over dx equals to 4 sec square u. All right. So from this, remember that your u is 4x plus 1. So bring it back here. This will be 4 sec square 4x plus 1. And that gives you the answer to this question. All right. Get another question that enables us to apply the chain rule or function of function. Now, it is called function of function because this in the bracket can be taken as what? As a function, let's say u, and entirely this is a function itself, that is the f of x function. Now, I can rewrite this and say, oh, my f of x is equals to y, and that is equals to 1 over 1 minus x squared. This can be written as 1 minus x squared raised power minus 6. All right. You should know that whenever you are given something like this, 1 over 6 is the same thing as 6 raised power minus 1. All right. That will make the work look simplified rather than working with this fraction. So now with this, we can tell that our u here is 1 minus x squared, and then our du over dx is negative 2x because we are looking at this. This is what we are looking at. That will give us negative 2x. And then our y will be equals to u raised power minus 6, and dy over dx, dy over du, that will be negative 6 u raised power negative 7, because this implies minus negative 6, negative 1. Negative 6, negative 1 is negative 7. So the dy du equals minus 6 u raised power negative 7. So if that is the case, we'll now come back and say, oh, you remember that your dy over dx is equals to dy over du. Always remember this, times du over dx. So dy over dx, what's your dy over du? Oh, the dy over du is this, minus 6u raised power minus 7. What's your du dx? Your du dx is negative 2x. That's what you get. Now multiply these together. If you multiply the coefficient of this and this, you get dy dx to be equals to 12x u minus 7. All right. Let's look at. So if we have this, okay, this, well, since we know that our u is what? Our u is 1 minus x squared, then our dy over dx equals to 12x 1 minus x squared raised power minus 7. And then you can put it in form of a fraction and say your dy over dx equals to 12x. This one will come as the numerator, and then you have 1 minus x squared is raised to power what? Is raised to power minus 7. Remember that this minus means 1 over. It's raised to power 7. No more. This is what you are going to get. And that is our answer to the question. Hello and welcome to this class. This is yet another question and the last one for this series that enables us to apply the chain rule under differentiation. So this is an exponential function of x. We are given y to be equals to e open bracket 3x plus 5. Remember, our dy over dx equals to dy over du times du over dx. It's often important to know where the u function lies. You can tell we cannot take this as our u. Rather, this here will be our u. So our u here is 3x plus 5. And then the du over dx, if you derive this, this will be 3. All right? Now, our y will be e raised power u. And the derivative dy over du is still e raised power u. Dy over du will still remain the same. This is an exponential function. If you derive it, it doesn't change. This doesn't change. It remains like that. Now, we now go back and say our dy over dx, which is dy over du, e raised power u, times what? Du over dx, that is 3. That's 3. So our dy over dx equals to 3e raised power u, and this will be 3x plus 5. 3x plus 5, and that is our answer.